Hi, today we'll be covering section 1.3, solving equations. So we're going to talk about how to write expressions from words. We're going to also take an algebraic sentence and turn it into words. We're going to look at the properties of equalities. We're going to see how we solve one-step and multi-step equations, and then solving for a variable in a formula. So write an algebraic expression to represent the verbal expression below. The example we have here is the cube of a number increased by 4 times the same number. So how would we write an algebraic expression for that? The cube of a number increased by 4 times the same number. So the cube of a number, so let's just call the number x. The cube of a number, so we would write that as x cubed increased, so we'd say plus 4 times the same number, 4x. That is how you would write that as an algebraic expression. So I want you to try the next one. Go ahead and hit pause and see if you come up with the same thing I do. Pause. Okay, 3 times the difference of a number and 8. 3 times the difference of a number and 8. So 3 times the difference of a number and 8. So the difference of a number and 8 is what we have to start with first. So if we just said x minus 8, that would be the difference of a number and 8. And then 3 times that, so we could just do 3 times x minus 8, that quantity x minus 8. So that's how I would do it. You may have had parentheses in a different place, but you really got to look at 3 times the difference of a number and 8. You have to consider that number and 8 together first before you can do 3 times that. Okay, now coming up with a verbal sentence to represent each equation. So if we have g minus 5 equals negative 2, that would be something along the lines of, you could say 5 smaller than g, or the difference between 5 and g is negative 2, or the difference between g and 5 is negative 2. That's probably how I'd say it. So the difference between 5, or between, sorry, between g and 5. You could also just say a number, the difference between a number and 5, equals, we usually just write as is, negative 2. Okay, so I want you to try this next one. It's a little bit harder, but go ahead and hit pause. Okay, let's see how you did. I would say 2 times a number is I would do something along the lines of is the same as, or is equal to, probably not as equal to, because we don't want to just read the sentence, but then we do the difference between the same number, the square of the same number, and 4. So we'll say 2 times the number is the same as the difference between the square of the same number and 4. Okay, moving on. Here's some properties. Go ahead and hit pause. You need to write these down for notes. Most of them are pretty obvious, but just write those down for notes so that you can have them. So go ahead and hit pause and write all those down. Okay, solving a one-step equation. So these are pretty simple. You can probably do these practically in your sleep by now. But let's just talk about solving equations. We always want to do the inverse to get something by itself. So if we want to get x by itself, in other words, if we're trying to solve for x, we need to get rid of that minus 14.29. So the inverse of that would be adding 14.29. Okay, and then to keep an equation balanced, if you're going to do that to one side, you have to do it to the other side. So we would do plus 14.29 and plus 14.29. So we added 14.29 to both sides. That keeps the balance. All right. The negative 14.29 and the positive, those cancel, leaving us just x equals 25 and 14 is 29. Sorry, not 29. Let's try that again. Is 39.29. So go ahead and hit pause. The next one, that says 2/3 times y equals negative 18. Remember to get rid of something, just do the inverse function. So go ahead and hit pause. Okay, first off, we're in high school now, so we write 2/3 like this. Okay, unfortunately, the computer doesn't let me type it like that, but just make sure you write your fractions so one's on top of the other like that. It's going to be way easier as you work with fractions to write them like that all the time. Okay, so a couple different ways we could do this. Number one, since 2/3 is multiplying, the way you get rid of it is by dividing by 2/3, because the inverse of multiplication is division. Okay, but then if we think to ourselves, I know that multiplying or dividing by a fraction is the same thing as multiplying by its reciprocal. That's the copy dot flip. So I'm going to write that as dot. I need to flip the 2/3 to make it 3/2, and 18 is really over 1. Okay, so we've got, again, dividing by 2/3 here is the same thing as multiplying by 3/2. And I just turned that negative 18 to 18/1, so it was a fraction. Okay, so we get y equals negative 18. I'm going to do the division first. Negative 18 divided by 2 would be, so if I rewrote it like this, negative 18 times 3, 2 times 1 is 2. So if I divide first, it doesn't matter, you could multiply first or divide first, it really doesn't matter. Negative 18 divided by 2 is 9, and then 9 times 3, sorry I forgot about the negative, it was a negative 18. Negative 9 times 3, so y equals negative 27. So there's our answer. Okay, now time to solve a multi-step equation. So I'll do this first one. So anytime you have parentheses, we have to get rid of those first. So we use the distributive property. All right, we're going to take that 3 and that 4x minus 2. So 3 times 4x to give me the area of this would be 12x. Then 3 times negative 2 is negative 6. Okay. So I'm going to take that, I'm going to put it in the equation. I have negative 10x plus 12x minus 6, okay, equals 6. All right, so combine like terms. This would be, I can put those two x's together right here. So that would give me 2 x because negative 10 plus 12 is 2, minus 6 equals 6, okay? Then I add 6 to get rid of addition, or to get rid of subtraction, I add, okay? So those cancel, it leaves me 2x on the left equals 12 on the right, so you can probably just use 2 times what equals 12. We know that 2 times 6 equals 12, so x equals 6. The other way you could do that is divide both sides by 2, and 12 divided by 2 is 6. Okay, go ahead and hit pause, try this one, and see how you do. Okay, well, we've got 2 things we need to distribute, so I'm going to write 2 generic rectangles, a 2 and a 2x and a negative 1, and this one has a negative 4 and a 3x and a 1. So 2 times 2x is 4x, 2 times negative 1 is negative 2. Over here we've got negative 4 times 3x is negative 12x, and negative 4 times 1 is negative 4. So now if I rewrite the equation, I have this part of the equation is 4x minus 2. And this part of the equation is the next generic rectangle, minus 12x minus 4. Then we have equals 2 to finish our equation. Okay, combine like terms, you get 4x minus 12x is negative 8x. Negative 2 and negative 4 make negative 6 equals 2. Okay, to get rid of that minus 6, I add 6 to both sides. So I'm at negative 8x equals 8. So we know x has to be negative 1. Okay, don't forget, if you ever want to check your answer, which is always a good idea in math, just plug and substitute back in for x here. We know x is equal to negative 1. Put it in place of that. So you just check is 2 times negative 1 minus 1, that quantity, times 2 minus the quantity of 3 times negative 1 plus 1. That's this part, plugging in the negative 1 for x. That quantity times negative 4. If you put those together, is it equal to 2? And you should get the answer of yes. Finally, if we're given a formula and we're trying to solve for a variable, what do we do? So first off, I apologize, the computer doesn't have pi, so that should say the area of a cylinder S is equal to 2 pi r squared plus 2 pi rh. So if we're going to try to solve this like it says here for h, we need to get rid of this 2 pi r squared. That's not with the h, so we need to get rid of that first. Since there's a positive sign technically in front of this, if we switch the order here, it would be 2 pi rh plus 2 pi r squared, so we think of it as addition. To get rid of addition, we're going to subtract, so let's rewrite it. S equals 2 pi r squared plus 2 pi rh. Again, like I said, treat it like it's addition right now, so to get rid of addition, we're going to subtract, so minus pi r squared minus 2 pi r squared. Okay, so those are not like terms. We cannot combine s and negative 2 pi r squared, so we just need to keep them separate. So it would be s minus 2 pi r squared. Okay, those cancel, so it's equal to just 2 pi r h. Now we need to still get rid of that 2 pi r h. To get rid of that, all of those are multiplying the h. So to get rid of multiplication, we do the inverse function, which is division. So divide by 2 pi r, and divide this whole thing by 2 pi r. Okay, so 2 divided by 2 is 1. Pi divided by pi is 1. R divided by r is 1. 1 times 1 times 1 times h is just h. So h equals s minus 2 pi r squared over 2 pi r. Now, I'll be fine with you keeping it here, but a lot of times you're going to see people split this up. So to split it up, because you're dividing both of these by the 2 pi r, you would write it as s over 2 pi r. Well, actually, shoot. We wouldn't have a pi in the denominator. They wouldn't like that because you're not supposed to really have irrational numbers in the denominator. So this would become a real mess. Like I said, I will take this as your answer. So just leave your answer in that form for me. But you will have multiple choice types of questions sometimes, so we need to be able to get from this answer to what will probably show up as a multiple choice. So number 1, split the 2 up. Minus 2 pi r squared over 2 pi r. Okay, notice those 2's will cancel, those pi's will cancel. This r will cancel with one of the r's, leaving us just an r up above, so it would kind of cancel that squared. From here, we would change it to s over 2 pi r minus, the only thing we have over here is r now. Okay, but this fraction, like I said, it has a pi in the denominator. There's not really much we can do about that. That's probably fine. So just leave it like that. That's probably how you'll see the answer. And I just looked at the answer in the book, and they actually left it as our original answer here. So that's great. It's always nice to see when that happens. A lot of times they try to overcomplicate things, but it looks like I did this time. That will do it for this lesson, so please bring any questions. Thanks.